So welcome. So in this lecture, I'm going to go through a chain rule example because it's going to be important when we're going to be undoing it for substitution that you kind of see this relationship. You're also going to, on occasion, need to apply it in different integration methods. So I already wrote it on the board because we went through it before, but let's just kind of remind ourselves of how it works. This is a situation where, and maybe it's clearest for you to see, I've written in several different ways. I don't know which way is clearest for you. Maybe it's clearest for you to see you have an outer function and an inner function. So I've kind of broken them apart over here. You have your outer function and your inner function, or as a composition. That's another way to look at it. And then what you're going to do is you're going to take the derivative of the outer function with respect to the inner function, and then the inner function with respect to its variable. So it's going to kind of look like this. That might seem a little confusing, except that it really helps to replace, like we did here, the inner function with a variable. So here we replaced it with u so that I know what I mean when I'm taking the derivative of u with respect to x and when I'm taking the derivative of f with respect to u. So let's focus in on this function for a moment. I've already kind of color-coded this similarly to above so that you could see. So here, pink is outer and green is inner. So let's go ahead and start working our way through this. So I've emphasized this a little bit, but it's good to explicitly write it out for yourself. Okay? So looking at this example, I can see, so my outer function, and we're doing this in green, or sorry, in pink. So here we go. So my outer function is going to be f of u. And let's just emphasize, let's keep all of our colors consistent to emphasize this is a function where there's actually a function inside of there, but we're going to forget about that for a moment. F of u is going to equal cosine of u. Okay? So I just clumped all of this inner function. I just replaced the entire thing with my variable u. And then I have my inner function. And now we're doing our inner function in green with the variable in orange, like we did up there. Okay, so this is my orange variable. Oops. Again, this is my orange variable. So let's go ahead and write that. So now we have that my inner function is going to be, so this is like my u or my g. So this is my u of x. So keep this variable straight. Is going to equal, and then I look over here, I have 3x to the 7th plus 1. So I have 3 variable to the 7th plus 1, and my variable is orange. Okay. So now I've identified, that's the first kind of key step in this often is to identify your outer and your inner functions. Sometimes people want to kind of do a lot all at once inside of their heads, and they end up a little bit getting, when they're not very explicit for themselves the first 50 times they do this, they end up kind of getting themselves a little bit confused as to what's going on. So it's often good to just take the time to set up exactly what you're doing and doing it carefully. Okay, so then I have now, what is my derivative of my outer function? So I'm actually going to do this over here before I even try to mess with anything over there. So let's take the derivative of this with respect to, remember, u. So I want to take the derivative with respect to, I remind myself it's a screen u, of, and then I'm taking this of, and then let's, so I have my function, which is cosine of u. So I can go ahead and take that derivative just like I normally would, and that's just going to be minus sine of u. Okay, so this is just going to equal minus sine of, and I'm going to leave that u green with the reason being that after I do all this, I need to plug that back in. Okay, so there's my minus sine of u. Over here, how do I take the derivative of this function? This one is just, so I take the derivative with respect to, and I'm taking it with respect to x. So I need an orange instead. So the derivative with respect to x of this, so I have 3 to the 7 plus 1. I'm keeping my variable orange, so I realize that I'm taking the derivative with respect to this. Everything is orange. Makes it sometimes easier inside of our heads. And this is like, we just know how to use the power rule here. This is just going to equal 21. And then I'm going to keep this orange just so that we can see. Orange is our final product variable. And then this goes to the 6th. Okay. Great. So now I have those to work with. So I look over here, and what am I supposed to do? I'm supposed to take really the product of these two things, right? This derivative here is the same as that one. This derivative here is the same as that one. So let's just kind of write this out. So this is going to equal over here. So I'm taking the derivative with respect to u of, and then I have my cosine of u. And then I need to multiply that by the derivative with respect to x. And then I'm taking of, and then I have this function, the inner function. So there I did the outer function, now I'm doing the inner function. And it's right above me, so that's very convenient. Then I'm taking 3, and again, I make this the color that's going to make it easiest to remember what I'm doing. Okay. Now I can just use what I already computed over there, and I get that this is going to be minus sine of u multiplied by, and then I look, so I took that from here, now I take the other from over there, so this is going to be multiplied by, so I'm taking this product with 21 x to the 6th. I'm not done yet, right? How do I know that I'm not done? Because I have two variables going on, okay? So I'm not done until my u disappears and I have everything in terms of x. Okay, so let's go ahead and do that. So I just need to replace this u, okay, from up here. So here it is. Here's my u. This is what I'm going to need to. So this part here, I need to sub this back in before I'm done. Okay. So I can go ahead and do this. So I'm just going to get, this is equal to, so I have minus sine of 3x to the 7 plus 1. Close this back up, and then multiply it just by there. Now everything's in terms of x, so I'm a happy camper. And the one thing I like to do, as I've kind of mentioned before, is to bring this in front so that it's clear what belongs inside of the sine function and what it's being multiplied by. So this is going to equal minus 21 x to the 6th times sine of 3x to the 7 plus 1. Okay. So what did I do? There's a lot of steps in here. Actually, and the last thing I do is I check that this matches up with what I have in my scratch work, and it does, so that's good. Or not scratch work, I have very carefully written up notes. We make mistakes too. Okay, so what did I do? I had a function where it was clear it had an outside and an inside, so it's a composition of two functions in a hidden way. So I just kind of identify for myself, what is the outer function? What is the inner function? So I did that. The outer function is cosine of u. So I replaced my inner function with u there. My inner function is u of x, which is 3x to the 7 plus 1. Okay. And I might even make a note for myself that u doesn't belong anywhere in the final answer. Everything should be in terms of x. So I'm going to have to sub this back in at the end. It's good to even make a note for myself of that. Now, it's also kind of nice to take my derivatives here where I don't have the confusion over when I'm dealing with u and when I'm dealing with x and so on. So I have the function, f is a function of u. I'm taking the derivative with respect to u. So I just went ahead and took the derivative like this would be any variable. Great. And then I did the same thing for my inner function. I took the derivative with respect to x. Now I can go back through and I can say, oh, well, how do I take the derivative of this function? Derivative of the outer with respect to inner times the derivative of the inner with respect to your variable. And then I just pulled those. It was nice that I did these over here so I didn't get myself confused. Then I can just pull these back over here. And then I remember, wait, I'm not done yet because I have both a u and an x. I want this all to be a function of x. So then I just go and I take my u function, my inner function, I plug it back in, then I can multiply the two and I'm done. Okay, so that's how we do the chain rule, and it's good to have this clear in your mind because you may need to use this in integration. Actually, some of the methods will require differentiating, but also seeing the process will hopefully make it clear how substitution is going to actually be kind of undoing this whole process. So thank you, and I will see you in the next lecture.